In this video, we're going to look at topic 89, example 4, simplify nth roots. So we're asked to simplify each expression. I'm going to rewrite these a little bit larger for us. So 32m to the 15th. Okay, so one of the first things we can do, and as you go through these steps and these problems, you'll start to get quite good at them, and some of these steps you will be able to skip. So what I am able to do is I can separate this into the fifth root of 32 times the fifth root of m to the 15. Now, do I have to do that? No, but I can, so I'm going to in this case. We talked about the fifth root of 32 in a previous problem, but if we go to math, option 5, and we take the fifth root of 32, we get 2. So let's just make that a 2 and be done with it. Now we have the fifth root of m to the 15th. Okay, so based on previous videos and examples and problems that we've gone through in our previous knowledge, we know that that radical can be rewritten as m to the 15th over 5. All right, so I can take this 15 and put that as my numerator, and this 5, my index, as my denominator. Now, 15 divided by 5 is pretty easy, and that's going to be 3. So I've now reduced that, and I have my solution, or my simplified expression. Now, for these specific problems in this example, all of our numbers are going to work out quite nicely in terms of the exponents, the fractions. We'll later get into what happens if, say, that was a 16 instead of a 15 and you can divide it evenly. But for now, what you should understand is that to find your solution, you would take the fifth root of 32, so the original problem gave us 2, and then what you can do is you can take this inside expression, inside exponent, and divide by your index. So 15 divided by 5 gave us this 3 here. As you get better at these problems, you can skip or cut out those middle steps. You won't always be able to do that, but for a problem like this is pretty simple because they're both perfect fifth roots. 32, you can take the fifth root of it, and 15 is divisible by 5. So that works out quite nicely. Okay, so it's the inside number, the inside exponent, divided by your index. A is pretty easy. B will be a little bit more work. There's one extra thing we have to look at. So here we have the fourth root of x to the 20th, y to the 8th. Again, if you want to separate it, feel free to. I'm not actually going to separate this one. I'm just going to keep it together. But I am going to do the 20 divided by 4. So that tells me I have x to the 5th. And I'm going to do y to the 8th. So the 8 divided by 4, which gives me y squared. So this is pretty much my solution, right? I just have to divide the inside exponents by the index. However, if you remember from our previous videos a little bit earlier, a couple videos back, when we took the even root, there was an exception that we had to look out for. We had to make sure that we were taking both the positive and negative roots. There's something quite similar here. If you're taking the even root, so if this root is even, and then your answer comes out to be odd, you need to put absolute values around that specific piece. Now the y squared, the 2 is even, so we don't need the absolute values because that term is always going to turn out to be positive. For these expressions, we're looking for positive roots, so we kind of have to force the numbers to be positive. Now, we don't really have numbers here, we're talking in terms of variables, but we want to make sure that these expressions turn out to be positive. And the way we do that is we use the absolute value symbols. So the rule is if you have an even root, and your answer after dividing comes out to be positive. Not positive. Let's rephrase that, or repeat that, fix it, correct it. If you have an even root, so this here, an even root, and an odd solution, odd exponent, you need absolute values around those pieces. Okay? You do not need them if it's even, you need them if it's even odd. So this is where we would stop. We can't do anything else with those absolute values. So one more time, if you have, say, the fourth root of, let's say this was x to the 8th and y to the 12th, this would be x squared, y cubed. You don't have to do anything with the x squared. but the y cubed would need absolute values. Okay, so keep that in mind. If it's an even index and an odd solution, you are going to need absolute values. Practice with 16 through 22. All of them will work out quite nicely. In a later section, we'll get to what happens if the numbers are not evenly divisible.